Info snippets to the Circle of Willis. The Circle of Willis supplies blood to the brain. Besides supplying blood to the brain, the Circle of Willis also delivers blood to the surrounding structures of the brain. Humans have a Circle of Willis delivering blood to the brain and its surrounding structures, and also other mammals, birds and reptiles have a Circle of Willis. The Circle of Willis is named after Thomas Willis. The way the Circle of Willis is arranged is so that in case of a blocked blood vessel, oftentimes the blood flow to the brain can be preserved through another blood vessel. Another idea is that the arrangement of the Circle of Willis helps to soften strong pulse pressure waves, and another one is that the arrangement of the Circle of Willis helps to sense upcoming dehydration. This text, titled "The Circle of Willis Revisited, Forebrain Dehydration Sensing Facilitated by the Anterior Communication Artery," by Matija Fenrich, Carlo Habjanovic, Josep Karan and Marisha Heffer, has under the section Abstract written: "We hypothesize that threat of dehydration provided selection pressure for the evolutionary emergence and persistence of the anterior communication artery, ACOA, the anterior arterial connection that completes the Circle of Willis, is early amniotes. The anterior communication artery is a hemodynamically insignificant artery, but, as we argue in this paper, its privileged position outside the blood-brain barrier gives it a crucial sensing function for the osmolality of the blood against the background of the rest of the brain, which efficiently protects itself from dehydration. Till now, the question of why the ACOA evolved and what its physiological function is have remained unsatisfactorily answered. The traditional view that the ACOA serves as a collateral source of vascularization in case of arterial stenosis is anthropocentric, and not in accordance with principles of natural selection that apply more generally. Diseases underlying arterial stenosis are associated with aging and the human lifestyle, so this cannot explain why the ACOA formed hundreds of millions of years ago and persisted in amniotes to this day. The peculiar hemodynamic properties of the ACOA could be selected traits that allow for more efficient forebrain detection of dehydration and complex behavioral responses to water loss, a major advantage in the survival of early amniotes. This hypothesis also explains insufficient hydration often seen in elderly humans. And under conclusion, the explanation that the function of the communicating arteries of a COA is to provide a collateral blood supply in case of arterial stenosis is anthropocentric and incorrect in light of the principles of natural selection. Atherosclerosis, the main cause of ICA stenosis, is typically a disease associated with aging and the human lifestyle, so it cannot explain why the COW formed more than 300 million years in early amniotes and persisted among living reptiles, birds and mammals. The PCOAs are remnants of primitive proximal segments of caudal cerebral arteries, hypoplastically remodeled due to the redirection of the blood supply from the carotid to the vertebrobasilar arterial system. The circumstances that lead to the emergence of the ACOA, however, are not well known. The ACOA neither affects the hemodynamics of the COW, nor does it present a functional anastomosis due to a lack of flow, making it unclear why such a blood vessel would be evolutionarily favored. We have presented an exhaustive review of the evolutionary history of the ACOA and its tight connection with the development of forebrain regulation of hydromineral hemostasis. We argue that the peculiar hemodynamic properties of the ACOA could be selected traits that allow for a more efficient and timely response to water loss. Considering that dehydration was a major threat to early amniotes, it could have created strong enough selection pressure for the emergence and persistence of this artery. Because the ACOA is susceptible to remodeling during the course of aging-related diseases, we propose that altered hemodynamic conditions in the ACOA may cause impairment in the forebrain detection of dehydration and hence a decline in voluntary water intake, making an individual more prone to hypernatremia and neurogenic hypertension. This paper provides the first explanation for the emergence and physiological function of the ACOA that is in accordance with the principles of natural selection.